Next up for derivatives is the quotient rule. Now it's got some similarities to the product rule, like as in like some quotients or division has similarities to products or multiplication, but honestly it's just a little more complicated. So if we have the derivative of two things, f of x over g of x, we're going to do g of x times the derivative of f of x minus f of x times the derivative of g of x all over g of x squared. So a little more complicated than the product rule. So taking a look at this first one, f of x equals x squared plus minus 1 over x squared minus 1. One thing we can do, I'm going to give these different letters. I'm going to call this top one a of x, call this bottom one b of x. And so a prime of x, we're going to need, it's going to be 2x, so coming from there, and then plus 1 coming from that x term. B prime of x is just going to be 2x, so the derivative of that denominator. So following along with the pattern we just learned, f prime of x is going to be equal to the denominator's derivative, so g of x, the denominator, not the derivative yet, x squared minus 1, times the derivative of the numerator, so it's going to be times 2x plus 1, minus the numerator, which was x squared plus x minus 1, times the derivative of the denominator, 2x. All that over the original denominator, x squared minus 1 squared. And honestly, for now, that's good enough. We can leave that as is. So that is our derivative, f prime of x. It is complicated. All right, for number 2, I'm going to label them similarly. Sine of x, we'll call that numerator a of x. Denominator, we'll call that b of x. So the derivative of the numerator, so derivative of a. The derivative of sine, if you remember back a couple pages, that's the cosine of x. Derivative of b, derivative of x to the fourth, is 4x to the third. So again, f prime of x is equal to the denominator, which was originally x to the fourth, times the derivative of the numerator, so times cosine of x, minus the numerator, sine of x, times the derivative of the denominator, and put that in parentheses, 4x to the third, all that divided by the original denominator, x to the fourth squared. You could simplify it a little bit, but honestly, that's okay as is. All right, number 3. We have f of x equals c squared minus x squared over c squared plus x squared, and c is a constant. So again, I'm just going to label the numerator. Well, how about this? Why wasn't I doing n of x and and d of x, numerator and denominator? That makes perfect sense. Brasser, goodness gracious, why didn't you think of that before? So let's do the derivative of the numerator first. The numerator's derivative, n of x, is going to be, well, the derivative of a constant, c is a constant, derivative of a constant is just 0. So really, we only need to take the derivative of negative x squared, so that's going to give us negative 2x to the first. Same thing in the denominator, that's just the constant, so the derivative of that constant is going to be 0, so we don't need to bother writing that. And then the derivative of x squared is just going to be 2x. So the derivative of the whole thing, we're going to take the denominator, the original one, c squared plus x squared, multiply it by the derivative of the numerator, so negative 2x, subtract from it the numerator, c squared minus x squared, times the derivative of the denominator, 2x, all that divided by the original denominator, c squared plus x squared squared. Yikes, lots of squares there. And again, for now, we don't really need to go any further than that, so we're just going to leave it as such. Number 4, we got g of x equals 1 plus the sine of x over 1 minus the sine of x. Again, just going to label the numerator as n of x, the denominator as d of x. Taking the derivative of the numerator, well, the derivative of 1 is 0. Remember, the derivative of any constant is going to be 0. So the derivative of the numerator, we're just really focusing on that sine of x. Derivative of sine of x is cosine of x. For the denominator, same thing. The derivative of 1 is just 0. The derivative of any constant is 0. So we just really got to focus on that negative sine of x. So taking the derivative of negative sine of x, it's going to be negative cosine of x. So starting to plug this in, g prime of x, take the original denominator, so we got 1 minus the sine of x, multiplied by the derivative of the numerator, so times the cosine of x, minus the original numerator, 1 plus the sine of x, times the derivative of the denominator, negative cosine of x, all that divided by the original denominator squared, so we got 1 minus the sine of x, in parentheses, the whole thing being squared. All right, these last two actually clean up a lot nicer than the other ones, so I think these ones will be a little more satisfying in some ways. So f of x equals 9 over 3x squared minus 2x. Again, numerator, call it n of x. Denominator, d of x. Derivative of the numerator, derivative of 9 is just 0. Again, the derivative of any constant is 0. Denominator, derivative of 3x squared is going to be 6x to the first, or just 6x, minus 2x to the first. Derivative of that is just going to be 2. All right, so the derivative of f of x, also full disclosure, when I was first making this video, I made a mistake. So I was going too quickly, so that's just my encouragement. Take it slowly at these beginning stages. So derivative f prime of x is the original denominator, so the original denominator being 3x squared minus 2x, times the derivative of the numerator, so that was just 0, minus the original numerator, which was 9, times the derivative of the denominator, 6x minus 2, all that divided by the original denominator, 3x squared minus 2x, that whole thing squared. Now, looking at this is actually kind of nice because some stuff here is going to cancel out. We got 3x squared minus 2x times 0. Well, anything times 0 is 0, so that's just 0. Now, we can also take this negative 9 here, distribute it to the 6x and to the negative 2. Well, negative 9 times 6x gives us negative 54x. Negative 9 times negative 2 is positive 18. Denominator, if you want to, you can go ahead and expand that out. I'm not going to bother. For time's sake, we got 3x squared minus 2x, that whole thing squared. So that is the simplified version of the derivative of f. One last example, and this is going to emphasize something that I mentioned in previous sections, but just making sure we reduce things right away so without, quite frankly, we don't have to do as much work. Looking at this, we got 3x over x squared. Well, notice both the numerator and denominator, well, first of all, they're only one term each. They both have an x, so I'm going to cancel out that x and also one of these x's. So we're just going to get 3 over x. That should make things a little easier. So again, looking at our numerator, we've got n of x. Denominator, let's call that d of x. Derivative of the numerator, so n prime of x. Derivative of 3 is 0. The derivative of the denominator, so derivative of just x is 1. This is going to end up being pretty nice. So for this one, we got h prime of x, take your original denominator, x, multiplied by the derivative of the numerator, 3, minus, nope, scratch that, I wrote the wrong number. I'm not going to bother rewriting this whole thing. There we go. 0, derivative of the numerator, minus the original numerator, now it's 3, times the derivative of the denominator, 1, all over the original denominator, which in our case, after simplifying, was x squared. Now again, just like in the previous one, we have something times 0, so that cancels out. So we end up with just negative 3 times 1. Well, I can do that. That's negative 3. Denominator, I mean, most of the time I've been saying, don't bother squaring it. We can just leave it as is. Well, x squared is just, well, x squared. So you can really just get rid of those parentheses. So we have h prime of x equals negative 3 over x squared.